carry is 1, then add it to the least significant digit of the number. And if it is 0, take radix minus 1 complement, and that is your place and actual sign. So this is the basic value. And if it is a 2 complement, so you have to find out the 2 complement of the subtrahend, add with the manuand, check the carry. If there is a carry, ignore and place positive sign. If it is 0, then you take 2 complement of the result. So this is the procedure forward. But our aim is not to deal with binary. Binary is your binary number. So there is that is used in your digital computer, and we are using 0 and 1 2 digits only. It depends upon the positional weighted system. Radix or base is 2, and 2 digits we are using 0 and 1. And if we combine the number of digits, so then we can get a number. For example, here is one number whose base is 2. 4 digits are combined here. So this can be written as by putting a B at the end, capital or small. So these numbers you can represent in any manner. So that is your binary number. So when you are representing the binary number, you have to give the base, either writing the B, capital letter, or lowercase letter. Small b you can use, no problem at all. Or you can put the 2 in the subscript. So the decimal number now can be converted into the binary number, no problem, by using the weighted sum method, by the successive division for the integer, successive multiplication for the decimal number. But the same number we can convert it into the decimal number by using the weighted sum method. So then if I write here single bit, so one bit means one binary digit. B and IT, 3 words we are using. B from the binary, IT from the digit. If we combine, it is known as a bit. Bit means single binary digit. If you combine the 4 bits, it becomes a 1 nibble. If you combine the 8 bits, we say it is a 1 byte. Most of the memory devices are storing the data as a 1 byte. Now the machines are going to handle 16-bit data, 32-bit data, or even 64-bit data. So we never say any name, so we say it is a one word of 16-bit. Generally we write here 16-bit words, just like 32-bit word, write it, 16-bit word. So 8 bits are written as 1 byte, 4 bits mean 1 nibble, single bit mean single binary digit. So there are prevalent uses are bit, byte and word. Word mean you are using the data size more than 8 bits. Then if we combine 10 bits, so we can get 2 power 10, 1024 possible numbers in binary. So we can get 1224 binary numbers. So that is known as 1 kilo. That is considered as a 1 kilo. Or in decimal, it can be represented as 1.024 into 10 to power 3. 10 to power 3 is 1 kilo. So it is written as a in binary. So 1 kilo in binary is equivalent to 1024, not 1000. So sometimes it is known as a binary kilo. So if we are going to combine 20 bits, it is represented as a 1 mega. It means 2 power 20. You can handle 10,48,576 numbers. So many numbers you will be able to store. So it can be represented as 1.048576 into 10 to the power 6. If I convert it into the exponent form, so 6 is known as mega. Similarly, 1 giga is 2 power 30, and it can be represented as 1.073741824 into 10 to power 9. So many numbers are obtained, and each number is of 30 bit. Each number is of 30 bit. Be careful. 1 tera, latest memory size of your hard disk is 1 tera. 1 tera means 2 power 40. 2 power 40 means 1.09951162776 into 10 to power 12. It means so many binary words you can obtain, and each word is of 40 bits. So 40 bits binary words you can obtain. So this is the important thing. So we are dealing with, if I am saying that I am having a 1 kilobyte memory, so size is there. So there are, you can store so many numbers, and each number is of 1 byte. So there are, so this is the size of the data, these are the locations. So 1K means 1024. It requires 10 address lines. Later on we will discuss how it is defined as. Then here is conversion is the same. Weighted sum method, only the base is 2. Now here digit is naturally, of course, is a binary digit, and binary digit can be either 0 or 1 only. So this is the position. If this is the number, I can convert this number into the binary by giving the here position. This position is here in this, from starting from your decimal point, you can have 2 power minus 1, 2 power minus 2, 2 power minus 3, here 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4. Because 5 digits are there, it will go up to 2 power 4. Here 3 decimal digits are there, fractional digits are there, that will go to power minus 3. So we can, if I explain it 1 in decimal, 2 power 0 is 1, 2 power 1 is 2 plus 4 plus 8 plus 16. If 0 is there, you ignore it. So 1 plus 2 plus 8 plus 16 is your number. So here 2 power minus 1 is 1 by 2, that is 0.5. 1 by 4, that is 0.25. 1 by 8 is 0.125. You can add, which is having a 1, 0 you can ignore. So this is 1 plus 2 plus 8 plus 16, 1 by 2 and 1 by 8. So you will get the number. This is the simplest way with which we can convert the binary number. So here is the same way you can start from 0. So this is 1, 2, 4, 8, 16, 32, 64, 128, 256, 512 and 1024. So this is your the value. 11 digits are there. You can go up to, so all the ones can be added. 1 plus 2 plus 4 plus 16 plus 64 plus 512 and 1024 you can add, and this is the number. But what will be the maximum number you can get from the 12 bits? So that is your 2 power 11 minus 1. That is the maximum value you can obtain from here. It is 248 minus 1. So this is the maximum size of the number in decimal you are getting. So this is the, but out of this here you are getting the number that must be within the range of 0 to 2 power 11 minus 1. So that is there. So it means what is 2 power 11 minus 1? It means you are having 11 ones. 11 ones. 1, 2, 3, 4, 5, 6, 7, 8. Here is 4 plus 4, 8 and 11. So you can ignore here 1. So you can count here 11 ones. 1, 2, 3, 4. 1, 2, 3, 4. So this is 1, 1, 1. So this is your number in binary that is equivalent to 2 power 11 minus 1 in base 10. Okay, what is the rule to find out the largest number in binary? So you can combine the largest digit, that is 1, of the base binary to get the largest number. So if I have to get a largest number of 4 bits, so that is I am going to combine one of the largest bit, 4 bits, so that will be equivalent to 2 power 4 minus 1 in binary, in decimal. So that is equivalent to 15. So you will find here the possibility. If I have to find out the smallest value, that will be 0 only. You are going to combine the smallest digit, that is 0. So here is a decimal number. So you are getting by the same way. But here, be careful. You are representing the binary number in a register. And a register has no provision to define the decimal value, decimal point, because decimal point is considered as an ASCII character. ASCII character means American Standard Code for Information Interchange. It is of 7 bits. So a register can adjust only the integer value. So why most of the computers are representing the data in the you can say most of the represented in the integer value. If I have to define the integer value how into the fractional part, then exponent forms are used. But here, this is a practical purpose. But we are unable to implement on the computer. Be careful. These are the combinations. It means one register is used for this purpose, one is used for this purpose, then I can add. In a register, we cannot have a 2 parts, fractional part as well as integer part. So if your register is 8-bit, it is able, 8-bit register is able to handle what is the data size? That will be 0 to 2 power 8 minus 1. So it means you can represent the number 0 to 255. 255. So when you are studying your data, when you are studying your C language, you are going to declare the data as a short integer. It means size of register is 8-bit. Then it is a signed or unsigned. If it is a unsigned, this range will be 0 to 255. If it is signed number, then you can represent in the complement form. So then it will becomes 2 power 7 minus 1 negative 2 power 7 2, that is 2 power 7 minus 1. Because it is in the 2's complement form. It is in 2's complement form. That is true form. But if you represent this is in the 1's complement, then it is 2 power 7 minus 1 negative 2, 2 power 7 minus 1. So you can represent the number as minus 128 to 127. Total number of numbers will be maybe positive or negative. That is 2 power 8. That is 2 power 8, 256. That is 256. You have to take care now. If your number is your integer, you are using a 16-bit number. If it is a sign, then it will vary from minus 2 power 15 to 2 power 15 minus 1. And if it is unsigned, it will vary from 0 to 2 power 16 minus 1. That is 65,635. So this is the way how we can deal with. So now binary conversion, we have to decimal to binary, we have to convert, follow the successive division. So find out the number, divide by 2, segregate the remainder and the quotient. Quotient is considered for the successive division and you can continue. So here is divisor 41. 41 is divided by 2. Here is a quotient and a remainder. Be careful. First is known as least significant digit. Now here we are using a binary digit, so that is represented by B. So it is not, it's a binary digit, so I'm using here LSB. Then 20 is divided by 2, 10, no remainder. 10 divided by 2, 5, no remainder. So 5 is divided by 2, 1, and 2 is further divided by 2, 1, no digit. So 1 is divided by 2, 0. Now here is 0, quotient is 0, you can stop. So your number is here D1, D2, D3, D4, starting from the least significant bit to the most significant bit. Here you can. If you are not defining the least significant bit, your number can be different. So you can represent this number as 100,101, which is wrong, because you are considering starting from here. In this way you are considering. You always represent the first remainder. First remainder after the division by 2 is giving you the least significant digit. Important point to note. So similarly here for the fractional part, you have to use the multiplication. If you multiply by 2, you consider fraction number as a multiplicand, multiply by 2, find out the integer and the fraction. Integer you will save separately, that will treat as a most significant bit of that fractional part only, and that fraction is used as a successive multiplicand for the multiplication. So here is 2-bit number is there, 2 up to 2 we can go up to 3 also, but here your fraction is coming out to be 0, you have to stop. So this is the way how you can get these numbers. So fractional here is 128 and convert 128. So this is 1000. So that is there. Okay, if I am representing here number is 128, or if I am representing 2 power 7 number in binary, how I can represent 2 power 7 in binary, in binary form, how I can represent, because this is a decimal number. Basically this is a decimal number. You can start from 0, it is representing 2 power 0, that is 1. So then 0, that is 2, then 0, that is 4. This is the place value. This is the place value. This is the weight assigned. Weight assigned. So this is the place value. Face value you can say. Then here 8, 0, then 16, 0. This is 32, 0. This is 64, 0. Then here is 128, because you want 2 power 7, here is 1. So this is 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6 and 2 power 7. So this is representing your number as a 7-bit number and represented in 8 bits. So similarly, now you can segregate the numbers in 2 parts. For the 205, perform the division. For 0.205, 0.5, perform the multiplication. 0.05, that is giving you 1, 2, 4, 8, 6 and 2. Now here repetition starts, so you can follow the. But you are not getting here 0, 0. You are not getting here 0, 0, but you can go up to a significant value that is there. Only repetition we have to follow. And now binary addition. Binary addition is 0 and 0, 0, 1 and 1, 0 and 1 is 1 and with carry, 1 and 0, 1. So this is 2. 2 is not a binary digit. So subtract minus 2. So you will get here 0. So basically what I am saying that 1 and 1 you are getting here 2. 2 in decimal. So this is in decimal. This is not a binary digit. What you have to do? You have to subtract the base of the binary. So you will get 0. So it means one time you are going to subtract. So here is 1. So here is 1. So this is the value way. But this is you are going in your brain. You are doing the calculation in brain. But it's a simple to say 1 and 1, 0 and 1 carry. This is the simplest form. So here is a decimal addition is given, 15 and 25 are added. So you know that 5 and 6 in decimal is 11, 1 carry, 1, 1 plus 2, 4. Now first 15 is first. Now in this case you have to decide how many bits are required to represent the data. For the 15, you use the 4 bits, but for the 26, you require 5 bits. 2 power 5, 2 power 5 minus 1. It means how many? 31. So it means you are first you have to decide that how many digits are required to represent the data. Now you are going to add here. So there is a previous carry is considered for the first digit as 0, 1 plus 0.